chapter 2.3. Last time we were looking at how to find the derivative of the function. Now we use the product rule. Suppose if you are given two functions with the multiplication, then we could use the product rule to find the derivative. So look at this expression. Suppose if you are given two functions fx and gx with the multiplication sign, product sign, then the product rule says that you could write the first function then times the derivative of the second function plus second function times the derivative of first function. Okay, so how can I apply this product rule here? So let me explain this product rule by looking at this problem. If you look at this given problem, example 1, you see there are two functions with the product sign. You're multiplying two functions. Okay, so here you could think of fx as x cubed function and gx as the second function, which is sin x. So the question is find the derivative of this entire function, right? So the question is finding dy over dx or y prime. So if you use this formula says that dy over dx is nothing but f times g prime plus g times f prime, right? So let us find those things here. You are given function f. How do you find then f prime? F prime is nothing but the derivative of function f. F function is simply x cubed. Remember last time we were going through the exponential properties, right? Power rule for the derivative. So if you find the derivative of x cubed, that's going to be simply 3x 3 minus 1, right? Where n is 3 now. If you use the power rule, now this is going to be 3x to the power 2. So that is the derivative of f. Then how about the derivative of trigonometric function sine? Remember last time we were going through the derivative of sine is simply cosine x, right? So you know basically f prime and g prime. So you could simply plug in here, right? So the derivative of the given problem x cubed times sine x is f times g prime. So f is x cubed function times g prime. G prime is cosine x. Then plus g times f prime. G is sine x. That's here. Then f prime, which is 3x squared. Okay. So that's the answer of the first problem. So product rule says that the derivative of f times g is nothing but f times g prime plus g times f prime. So in short form, you could write like this. This could be written as simply the product derivative, right? So you could use this notation as well. So if you put f times g prime, meaning is you are finding the derivative of the function f times g. So formula is simply f times g prime plus g times f prime. Okay, so you could use this notation as well. So we could think of this one as f function and this is g function, and could you think about applying the product rule for this derivative? So why don't you try this like I did in first problem? That is about the product rule, right? Now the quotient rule. Suppose if you are given two functions in rational form f over g, then how do you find the derivative of this function? Formula says that the derivative of f over g function is nothing but the bottom function times the derivative of top function. You could think of this as a top function and this is the bottom function. Okay, so the quotient rule says that f over g derivative is nothing but the bottom function times the derivative of the top function f, then subtract the top function times the derivative of bottom function, and divide everything by the bottom function square. You could use this formula, you know, to find the quotient rule form. Okay, so let us do one more thing here. The denominator function should not be equals to 0. If the denominator function is 0, it is undefined, right? So you will not get any, real derivative answer. Therefore, this condition should be there for the quotient rule. The denominator function always should not be equals to 0. Okay. So now, can I apply this rule to the given problem? Number one, yes, we could, right? So this is in rational form. So you could take a numerator function as f function and the denominator function as a g function. Okay. Now, if this is the case, you know how to find f prime. F prime is nothing but the derivative of 3x minus 4. The derivative of 3x is simply 3. Then the derivative of constant is 0. Remember last time we were going through the properties of the derivative of constant function, which is always 0, right? So that is 0. So answer is simply 3. So here g prime function is nothing but the derivative of 1 plus the derivative of x squared. Again, derivative of 1 is 0 because of the constant. But if you use the power rule for this derivative, it's going to be 2x, right? I'm using the power rule, so that is simply 2x. Okay, so I know g prime and f prime, so simply plugging this into this formula, quotient rule formula, you will get the answer. Okay, therefore, the given problem was this. So the derivative of this function, that is simply y prime or dy over dx, is nothing but, I'm using this formula. Okay, formula says that this is nothing but g times f prime minus f times g prime over g squared. Okay, so let us plug in the values now. So g function is 1 plus x squared, that is here, times f prime is simply 3, then subtract f function is 3x minus 4, right? Then multiply this guy with g prime. So g prime is here, which is simply 2x. Okay, so then you have to divide everything by bottom function squared, so which is g squared. So g is 1 plus x squared. So we have to square this. Okay, so if we could simplify this answer, that's fine. So let us simplify this further. So you could distribute 3 with 1, 3 with x squared. Similarly, 2x with 4x, 2x with a negative 4. You distribute. So you will get 1 times 3 is 3, plus 3 times x squared, 3x squared. Then I'm multiplying 2x with 3x, which is 6x squared, but you see the negative sign, so that is minus 6x squared. This is minus 4 times 2x is negative 8x, but here you have negative, so it's going to be positive 8x. This all over 1 plus x squared whole thing squared. So if you simplify further, let us combine all x squared term, which is going to be negative 3x squared, then the x term, then I'm writing the constant. So this all over 1 plus x squared whole thing squared. Okay, so this is the simplified version of your answer. Always it is better to simplify. Okay, so why don't you think about the second one then? Finding the tangent line to the graph of fx at the given point 1, right? Okay, so remember we were going through this problem, like similar problem in chapter 1, finding tangent line. So here also you could, apply the same procedure. So first, let us find out the slope of the line. So the slope of the tangent line, remember, always given by the derivative of the function, right? So slope of the tangent to the graph of f is simply, f prime, right? That means you need to find the derivative of this function first. So let us find the derivative of f function. Remember, f function is now this guy, that is a rational function. So you could use, the quotient rule to find the derivative here. So the bottom function is 4x cubed plus 1, and the top function is 3x squared plus x minus 2. So I'm applying that quotient rule here. So the quotient rule says bottom times the derivative of top okay, then subtract top function, which is 3x squared plus x minus 2. So top function times the derivative of bottom function, then this all over the bottom function squared, right? So this is the quotient rule. Okay, so let us simplify further. This is 4x cubed plus 1. Now you need to find the derivative of this guy, 3x squared plus x minus 2. So that is, you have to use the power rule for each term. So the derivative of 3x squared is going to be 3 times the derivative of x squared is 2x, then plus the derivative of x is just 1, using again power rule. Then the constant negative 2, derivative is always 0. I'm not going to write that. Then subtract 3x squared plus x minus 2 times the derivative of 4x cubed plus 1. Again, using the power rule, the derivative of x cubed is 3x squared. Then again, the constant is 0. So this is the answer you get, right? So this all over, the denominator says 4x cubed plus 1 whole thing squared. Remember, we are finding the slope at the given point 1, right? X is 1. So if you're plugging x1 here, you will find the slope of the tangent line at 1. So simply plugging 1 into x. So let us simplify this by plugging 1. So if x is 1, you will get that is 1 cube, right? Plus 1, everywhere plugging 1 for x. 2 times 1, and the plus 1, sorry. Okay, then subtract 3 times 1 squared plus 1 minus 2. And this times 4 times 2 is 12 and 1 square, right? This all over 4 times 1 cube plus 1 whole thing squared. So you have to simplify this. Okay, so if you simplify, what you'll get? So you will get 11 over 25. Okay, 11 over 25. So please make sure to check this answer. Okay, so you know the slope. Basically, this is going to be the tangent line, slope m, So you know the slope. You need to find out the y coordinate of the point, right? So remember, you know the x coordinate of the tangent point, which is 1. How do you find y? Simply plugging into function to get y, right? So the y coordinate of the tangent point is simply f of 1. Okay, so I'm finding the y coordinate of the tangent, which is f of 1. So take the function, plugging 1 there, you will get 3 times 1 squared plus 1 minus 2 over 4 times 1 cube plus 1. Okay, so if you simplify this, you will get 2 over 5. So that's going to be the y coordinate of the tangent. This is different problem. Okay, so this is y coordinate of the tangent point. So this is x coordinate. 1 is given. Therefore, tangent point is now, which is 1 comma 2 over 5. You know the point, you know the slope. Slope is 11 over 25. So you know how to find the straight line, tangent line. So therefore, equation of the tangent line simply y minus y1 formula equals m times x minus x1 formula. So you know this is x1 and this is y1. You are given a point, right? Tangent point. So now plugging all the values, you will get the line y minus y1 equals slope is 11 over 25. Then x minus x1 is 1. Okay, so if you simplify this and rewrite, you should get the straight line formula, which is 11 over 25x, then minus 1 over 25. This is the equation of the tangent line for the problem. First, find the derivative. Always, you need to find the derivative if you want to find the tangent line slope. Then plug in the values. Okay, since the given function is now quotient function or rational function, that's why we use the quotient rule to find the derivative. Okay. Now, like earlier, here also we have set of, the derivative of trig functions. Further, the derivative of tangent function is always going to be secant squared function. The derivative of cotangent is going to be negative cosecant squared, and the derivative of secant is going to be secant x times the tangent x, and the derivative of cosecant x is negative cosecant x times cotangent x. So remember all four formulas now. Okay. So there again, for this example, you are asked to find the tangent line to the graph of this now. This is now, trigonometric graph. So the given point is now pi over 4. Okay, so first you need to find the derivative y prime of the function. So that is the answer here. Use the product rule to find that. Okay, so how can I get this answer? You understand? I will explain here. So the given function y was now tangent x times secant x. Remember now, this is your, product function, right? This is in product form, but trigonometric function. So the given point was pi over 4. First of all, you need to find y prime. You have to use the product rule, right? The product rule says y prime is nothing but f times g prime plus g times f prime using the product rule of the derivative. So if you use the product rule, what is f function? That is nothing but the tangent function. Okay, plus, sorry, times g prime. G function is secant x, but we know the derivative of secant x is here. The derivative of secant x is nothing but secant x times tangent x. Okay, then plus g times g function again secant x function is time f prime, the derivative of f function, that is the derivative of tangent. The derivative of tangent is again we have here, which is secant square. Isn't that? So now if you simplify, you will get what? You could multiply these two, all multiplication sign. So tangent x times tangent x is tangent square x, then times secant x, then plus secant x times secant squared x is going to be secant cube x, right? That's why if you look at the answer, you have this expression here. Okay, that is simply the slope of the tangent line of any point x, but we are interested in pi over 4 point, right? So that means you could plug in pi over 4 here to find the slope of the tangent line at the point x is equal pi over 4. So if you plug in that value for the function pi over 4, you will get simply tangent pi over 4 squared times secant pi over 4 plus secant cube pi over 4. So now you know the values of these, right? By the unit circle, you could find all the values and simplify. Remember, tangent pi over 4 is 1. Secant pi over 4 is square root 2. Then if you plug in those values, you will get 1 squared times square root 2 plus square root 2 cube. That is square root 2 plus, remember square root 2 cube is 2 times square root 2. Then you will come up with 3 times square root 2. That's why you see that answer here, the slope at the point pi over 4. So this is nothing but m now, slope. So like earlier, you could use y minus y1 equals m into x minus x1 formula to find the tangent line. Remember, you are given only x coordinate, right? You have to find always y coordinate by plugging pi over 4 into the given function. Okay? The given function is now the original function, okay? This guy. So plugging x pi over 4 here, okay, then you have to find y. Y is nothing but tangent pi over 4 times secant pi over 4, which is simply square root 2, okay? So the y coordinate is square root 2. So all the time you need to find the tangent point if you are given x value. So the tangent point, x coordinate is given, pi over 4, if you're plugging into the function y, you will get square root 2. You need to find this guy, right? Plugging pi over 4 for x into original function y. You will find that. Okay, that's it. When plugging those values, you will get the tangent line equation. That is there. So why don't you think about this problem and make sure that you understand this. Again, use the quotient rule to find f prime first. Okay, after that, use that normal procedure to find, simplifying and writing simplified version. So this is the simplified version. So make sure that you get that answer. Let me know if you are not getting, then I could explain next time. Okay, so let's move on. These are the notations you could use for the derivative. This all we discussed last time, right? The first derivative of function y is given by y prime or f prime or dy over dx or d over dx of fx or dxy. So you could use any notation, right? Okay, to denote the derivative of the function y is equal fx. Okay. Now, if you want to make second derivative, that means the derivative of the first derivative is always going to be the second derivative, okay? So the second derivative of the function, we write d2y over dx2. The meaning is you are finding the derivative of dy over dx, the first function derivative. Again, you are taking the derivative, right? With respect to the same variable x. This is called the second derivative of the function y with respect to x, okay? So this could be written as like y double prime and so on. Okay, that is there. So now I'm writing here some exercise problems. Why don't you try from your textbook or web design? Try problem number 10 from 2.3 and problem number 15. Problem number 45. Problem number 47. 49. Just to practice, okay? And the last one, 58. You can try these problems. Anyway, I'm going to upload the solutions with the worked out class note maybe after a week, but you need to practice first, okay? So this section is simply about the quotient rule and the product rule, applying them to trigonometric functions. Then after that you could use these applications to find out the tangent line is there. Okay, so this is 2.3 plus 2.4. So I need to take 2.4 now. Okay, 2.4. So we are going to learn some more properties on derivatives. This is called the chain rule. Okay, chain rule says that suppose if you are given a function y function with the variable u, and if you know u function in some other variable, say x, then the composite function of f(g(x) always could be differentiable. The composite function answer is always going to be dy over dx, which is equals to dy over du, u coming from the first function, then du over dx coming from the second function. Or in another word, the derivative of composite function, remember this is not multiplication, this is not product, this is composite function, right? So we learned about composite function, we call it algebra. So the meaning of this is combining two functions, right? That's the meaning, not the product. Not the product, okay? So the composite function derivative is simply, we write like that. Formula says that this is nothing but find the derivative of f function, then replace x by gx, then multiply the inside function gx derivative. That's it. This is called of the chain rule. Okay. Always you see two functions. There's one function inside the other. Okay. So look at this example. Suppose if you are given a function y is equal 3x to the power 4 plus 2 and 99. Okay, so you could rewrite this function in composite form with this substitution. Okay, you could think of fu function as u to the power 99 and u function as just 3x to the power 4 plus 2. If this is the case, then we will get f of gx, okay, that is given here 3x to the power 4 plus 2 is all to the power 99, okay. What I'm trying to say is always it is possible for you to write the given function in composite form f and gx, where f function is the variable u, which is u to the power 99, and inside function u is nothing but 3x4 plus 2. Okay, so then you could apply the chain rule to do this. Okay, so look at the steps here. First, you need to find the f function derivative. F function is here in terms of u. So the derivative of f respect to u is going to be 99 u 98 using the power rule, right? Then you know the g function. G function is inside function, right? You know the g function, gx. That is 3x4 plus 2. So you could find g prime as well. That is 12x cubed, right? So then apply this formula to find the composite function. So that's why this step you are seeing. So f prime function is here, 99 u to the power 98. You are finding f prime function but replacing u by gx now. That's why in place of u, you see gx function. Gx function is nothing but 3x4 plus 2. Then you see the power 98 times g prime x. You see the formula? F prime gx times g prime x. In other words, the derivative of g, which is we know 12x cubed. So simply plugging them. So you will get the answer, okay? So it's easy way to think. Always remember this. A device to help remember the chain rule. Outside function derivative, then plugging inside function times the inside function. Okay, so that's the order. So here outside function is f, inside function is g. You see that here? This is outside function, this is inside function. Always find the derivative of outside function first, then inside function. Let's call, the chain rule. Okay, so the general power rule, there is another rule. Suppose if we are given a function u, then what's the derivative of u x to the power n? You could use the chain rule to get the answer. So the dy over dx is nothing but using first the power rule. So the power rule says n times function, then n minus 1 times the inside function. You could think about this, like a composite function. Okay, so how can I think this as composite function? This is the way. You could think of this as like x. This all u function you could think of like x. Okay, I'm talking about the inside function u is you could think of like x. So this question is like x to the power n derivative. How do you find by derivative? Power rule. X to the power n derivative is going to be n times x n minus 1. But my x was ux, right? This was my x, right? Then n minus 1. Then, after finding the derivative, always multiply and put the inside function derivative. Inside function is ux, right? And simply find the derivative of u function. Okay, so in notation wise, this is nothing but uxn minus 1 times u prime means we know d over dx of u. That's the meaning, right? U prime. So this is called a general power rule. Inside the function, you will see one more variable. U variable. Inside the U variable, you see X variable. That's why this is called as the chain rule problem, because you will see two functions all the time. Okay, so in short form, you could write like that. U could be any function. If you take the derivative of u to the power n with respect to x, this is nothing but n u n minus 1. Then take the derivative of inside function u, which is u prime. All the time, remember the formula. Chain rule. Now look at this problem. So the given function is now x to the power 4 plus 1 square root. Okay. So now you could think of inside function x to the power 4 plus 1 as u, right? So this is nothing but u to the power 2 function, okay? So if you want, I could write in detail. This problem is like this. Okay, you could think of whatever you see inside the square root, you could think of that as function u. Okay, I'm telling you, u function is nothing but x to the 4 plus 1. If this is the case, you could rewrite the given problem simply square root u, right? We all know that square root means half power, right? That means the given problem is now y is equal u to the power 2. Question is finding the derivative, right? You see, question is finding the differentiation. So the formula says that u to the power n, look at here the formula, u to the power n times un minus 1 times u prime. So if I use that formula, y prime is going to be, now remember the power rule, n is half. If I use the power rule, this is half times u half minus 1 times u prime, right? Need to take the derivative of u here. Now this is going to be u negative half. What is u prime? You know u function, right? This is u function. So u prime is nothing but the derivative of x4 plus 1. The derivative of x4 is 4x cubed. Again, using the power rule. The constant one is nothing but 0. Therefore, u prime is nothing but 4x cubed. So 4x cubed. So this will be 1 over 2 u to the power 2 times 4x cubed. Now remember, function u was nothing but x to the power 4 plus 1, right? So I'm rewriting u function in terms of x. That is x to the power 4 plus 1 half root. Now if you simplify this, 2 gone, so you will get 2x cubed over x to the power 4 plus 1 to the power half. You all know that half power is nothing but square root. That's the answer. Okay. Easy way I could suggest you to think about like this. Okay, I could do this problem like whatever inside you could think like x. So this problem is like x to the power half. You know the derivative of x to the power half. Half times half minus 1, right? That's why you get this. But you know what x was? That guy. After that, find the derivative of that inside function, which is 4x cubed. So this is the short version. Okay. Okay. So please go through this all the problems and check whether you understand all the steps and watch the videos on these sections. Again, I'm giving some problems to work on, and I will post the solution for 2.4 as well. So you could try your own, try some problems from the text. Okay. So let me know if you have any questions. I know this is going to be a little bit difficult, but anyway, so you just go through my class notes, videos, and watch the web design videos and try to understand. Okay.